Hi, this video will talk about the concept of interference, um, and then we're going to take that and use that interference to talk about some of the harmonics in music, in musical instruments. So interference is basically, as the word says, is like when two waves are coming at each other, they interfere, and something new comes out. Okay, so let's just say I have a wave like that, and I have another wave like that with the same amplitude. They come in and they're going to meet, okay, or two pulses. You can probably see that when they meet, they're going to cancel each other out if they have the same amplitude. So let's call this wave, this pulse A and this pulse B, and when they pass as if the other one didn't even exist. So B will be here and A will be there, and it's like nothing ever happened. Now, those are extreme cases, okay? So now, let's say we have a wave that's coming this way, okay? And it's gonna meet with this. Again, you're gonna get a bigger wave, and B will pass, and A will pass like nothing ever happened, okay? Well, you have everything in between. So that's what we call the beats. Okay, so when two waves, okay, interfere and their frequencies are slightly off. Okay, they're a little bit off. You hear these high and lows, and we'll talk about that in class. I'll show you what it looks like, and I'll let you hear it by playing two different signals, or signals of frequencies that are close to each other, and you're gonna see that you're gonna hear the high and the low notes. For now, let me take that to the harmonics. And I'm gonna do three cases. I'm gonna do something that's closed at both ends, like a guitar string. I'm gonna do something that's open at both ends, like the flute. And I'm gonna do something that's open at one end and closed at the end, at the other, like a saxophone. So let's look at something that's closed at both ends, okay? So let's say, let me exaggerate this. Let me say I have a string that has this long, and I'm gonna pluck it, and I'm gonna send a pulse, right? Then I'm gonna get a reflection. And I'll let you see all this in class. Okay. So in this here, in that length of the string, I'm able to get half a wave. And I'm gonna write it like that. And you'll see in a second why I'm doing it like that. Now, the next case will be, well, I'm gonna send the pulse. I'm not good at drawing, but I'm gonna try my best. So let's say this is the halfway. Yeah, and then here is the reflection. Okay, so in this here, I get L equals, it looks like I have two halves, half and half, which is a full wave. But I'm gonna do everything in halves, because everything happens in halves. The next one, I think I'm gonna do something like that. Let's see. Okay, so I'm gonna do one more. Something like that, not drawn to scale by any means. So in here, in this length of the string, I'm able to fit half, two halves, three halves. And I can continue with this pattern. So L is going to be some number n, lambda over 2. So we call this the fundamental of the first harmonic, second harmonic, third, and nth harmonic. Now, we also know that V is equal to lambda times frequency. So I think I can isolate the lambda here in the general form. It's going to be 2L over N. So I can put that in here. So V is going to be equal to 2L over N times frequency. Okay? Now I'm going to solve for the frequency. F is equal to N V over 2L. And this F is the number of the harmonic. So in other words, if I want to find the fundamental or the first harmonic, I put a 1 here. Second harmonic, I put a 2 there, right? And you can see clearly that this Fn is just a multiple of the fundamental, because the fundamental is just V over 2L. So this is basically N times F1, okay? And N takes numbers like 2, 3, 4, 5, 6, etc., right? Okay, so that's one. So let's look at something that's open at both ends, like a flute, for instance. Okay, so it's open here, and it's open there. And it looks like that, okay? So I see a quarter here, and I see another quarter here. Okay, so L, the length of the tube, the air column basically, is, what did I say? It's 2 quarters, so it's a half. Okay, the next one, I have to open it here, do that, and that. So it's gonna look something like this. Okay, so I have a quarter here, I have a half here, and I have another quarter here. So L will be, so this is a full wavelength, or 2 halves. I have half here, and between these 2 quarters I get another half. 2 halves. And I can, if you notice, I can continue with this pattern, right? And I'll end up with the same thing as for something that's closed at both ends. So again, the Fn for something that's either open at both ends or closed at both ends is just NV over 2L. The V is the speed of sound either in that guitar string or in this atom of column. This is like a pipe, kind of, okay? Like a tube, pretty much, okay? And I will demonstrate this in class. And you say that what I'm doing is true. So N takes numbers like 1, 2, 3, etc., right? Now let's look at something that's open at one end and closed at the other, like a saxophone. Okay, so here, it's closed here, but opened here. Let me exaggerate this. Okay, so it has to stay open, and the only way it stays open there if I do a quarter. Okay, and it reflects at the end here. Okay, so L, this length of air here, of air column, looks like it's a quarter of a wave. Okay, the next one will look something like this. Well, you can't do half because you will close it. So you have to add an extra quarter. So it's gonna look like that. So in this here, it looks like I have a quarter and a quarter and a quarter. So I have 3 quarters. The next one, you probably can see it, is gonna be 5 quarters, right? So now this formula, so this is open, open, or closed, close. Okay. The next one I'm gonna do, and if you follow the same process I did earlier, you do V equals lambda times frequency. Lambda here is what? 4L over, if you continue this pattern, over N. But here's the thing. You can see that N skips. N is odd. And if you take that, lambda and you put it in here, what do we end up with? We end up with V equals 4L over N times F. Okay, Fn basically. So which means that Fn is NV over 4L, and N skips. So this is NV over 4L with N being odd. Okay, all the odd integers. Okay, and that's pretty much harmonics. Now, I will make you see this by actually doing some demonstrations in class with the string or with the tube that's open at both ends, closed at both ends, things like that. Okay, and that's pretty much wave interference and harmonics. Thank you. Have a good night.